Let us discuss one function f of x is equals to mod x f from R to R, whether it is bijective or not. To become its bijective, it must be on 1 and on 2. So we can check the condition for on 1 and on 2. To prove it is 1 1, we need to prove f of x1 is equals to f of x2 implies x1 is equals to x2. But to disprove, any counter examples are enough. So better you give counter examples for disproof. As you can say, f from R to R, f of x is equals to mod x. Already we know the definition for mod x. Suppose if I write modulus of 2, which is equals to how much? Modulus of 2 is plus 2. Even if I write modulus of minus 2 is equals to how much? Plus 2. Therefore, mod of 2 is equals to mod of minus 2. But 2 not equals to minus 2. Therefore, this function is not 1 1. So f of x1 is equals to f of x2, but x1 not equals to x2. Therefore, this function is not a 1 1 function. Similarly, we know that range of modulus function is set of positive real numbers. So that negative real numbers, if you consider, next I will consider onto function. So if you choose some minus 5, not necessarily minus 5, you consider any negative value belongs to R. To become a onto function, for every value belongs to R, there must be some value belongs to this R such that f of x is equals to this value. But we don't have such value in R. By applying modulus of that value, we get minus 5. Therefore, there exists no x belongs to R. There exists no x belongs to R such that f of x is equals to minus 5. Therefore, this function is not onto. So this is neither 1 1 nor onto. Hence, it is not a bijective function. Similarly, we can define f from R to R. F of x is equals to 1 if x greater than 0, 0 if x is equals to 0, minus 1 if x less than 0. Particularly, we call this function as a signum function. So this signum function is also neither 1 1 and nor onto. So this function is also not onto. Now signum function. So if I consider f of 2 means 2 is greater than 0, therefore f of 2 is equals to 1. Similarly, if I consider f of 3, this 3 is also greater than 0, therefore we get 1 again. Therefore, f of 2 is equals to f of 3, but 2 not equals to 3. Therefore, this function is also not 1 1 function. This is not 1 1. Next, we shall check onto condition. So, for onto condition, for all y belongs to R, there must be a x belongs to R such that y is equals to f of x. You can see range of this function is 1 0 minus 1. You apply any value for x. You apply any value for x. If you apply 1 2 3 4, these all values connects to 1. 0 connects to 0, minus 1, minus 2, minus 3, minus 4. These all values, minus 1 connects to minus 1, minus 2 to minus 1, next minus 3 to minus 1, minus 4 to minus 1. So here you have this 2, 3, 4, minus 2, minus 3, minus 4, because this is R, this is also R. If you draw this arrow diagram, then also you can clearly observe that this is not 1 1 and this is not onto. But for proving not onto, we need to write like there exists some 3 belongs to R, but there is no such x belongs to R. There is no such x belongs to R such that f of x is equals to 3. Therefore, this function is not onto. Therefore, this is neither 1 1 nor onto.